everyone. Welcome to the OpticStudio 16 new release webinar. I'm your host, Akash Arora, and I'm the product manager here at Zemax. Today I want to talk to you about the new features that we've added to OpticStudio 16. OpticStudio 16 was released Tuesday, April 26th. The key new features available are single user soft key licensing, several features related to manufacturability, including Opto-Mechanical Semi-Diameters, an improved non-sequential conversion tool, a design lockdown tool, two related tools, a critical ray set generator and a critical ray tracer, additional non-sequential objects as detectors, and a new wavelet construction method for the Huygens PSF. For those of you attending this webinar live, there will be a question and answer session following the live webinar. Let's first talk about single user soft key licensing. With OpticStudio 16, soft key licensing is now available for single user keys. So no longer is a USB dongle required to run OpticStudio. Some of you may have been aware that with OpticStudio 15.5, released in October of last year, network soft key licenses were made available with check-in, check-out capability, and many other IT support capabilities that make them superior to the hard keys. With single-user soft keys, you can activate the key, upgrade the key, and also update your support status with a digital code that's provided by Zemax. You can still transfer keys easily between two machines using an easy transfer process. Also, there's an enhanced license manager that allows you to view license information. Let's take a look at how this works. If I open OpticStudio 16 and go to the Help ribbon, you'll notice the icon for the license manager here in the information section. When I launch the license manager, it's going to look for all of the available licenses either plugged into my machine or visible on my local network. And as you can see, there are several licenses that we are using here on Zemax's network, many of them test licenses. For those that are network licenses, as many of these are, you'll see the checkout option available. For single user licenses, the main buttons that will be available are the ability to transfer and update the license. In addition, for every license, you'll see a key serial number, a key ID, support expiration date, the type of license, be it network or single user, the edition of the product, standard, professional, or premium, and if it's a network license, you will see how many seats are available out of a total number on the network license. As I said before, for a network license, one advantage is that you have the ability to check out a license and use it disconnected from your company's network and from the internet altogether. That's a capability that's unique to the network license. For the single user license, if you want to transfer the license to a different machine, you can use the transfer away capability, or if you want to update the edition or the support expiration date, you can click the update button and that will be active as well. When you first try to run the software, if no key is recognized, OpticStudio will open the license manager to the new key section. And this is where you can take the activation code that you've received from Zemax and enter it in the activation dialog. If you want to transfer a key, it's a simple three-step process. You first generate a transfer code, enter that transfer code on the machine that you want to transfer it to, and then complete the transfer. There's also a help section here that provides dynamic information depending on the type of key you are using, be it a soft key, a green USB key or a black USB key, and it will provide you links to knowledge base articles as well as other information that may be of use. So this is the license manager and the enhancements to the license manager. An additional capability that you'll see down here is it will recognize a black USB key that is hooked up to your computer as well. Now, if you're using a black USB key, most of the information that you need is still available here in the Help About dialog with your support expiration date, the edition of the software that you're using, and the serial number. If you'd like to trade in your hard key license for a soft key license, that's something that we will support as long as your software maintenance contract is current. And if it is, there's no charge for that key trade-in. Let's talk about now some of the manufacturability improvements to OpticStudio 16. The biggest one is a new way of defining semi-diameters. In OpticStudio 16, there are two additional diameters that you'll see in the lens data editor, a chip zone and a mechanical semi-diameter. And the way that this works is the semi-diameter column operates the same as it has in all previous versions of Zemax and OpticStudio, where it defines the clear aperture of the optic. The chip zone represents a region that follows the same curvature as the clear aperture, but is typically a coating fall-off area and a region of the optic that's not held to tight optical standards. Beyond that, you have a mechanical semi-diameter, which represents a mounting region at the edge of the optic. These new semi-diameters have been extended throughout the program, so you'll find that they're used in optical drawings. There are new multi-configuration operands for thermal analysis. There are new optimization operands for optimization purposes, and they're also supported with tolerancing as well. In addition, we've added ZPL and API commands that allow you to change and get the data that's entered in these cells. For backward compatibility, you will be able to read in files that don't have chip zone and mechanical semi-diameters defined, and in those cases, those values will be set to 0, such that the semi-diameter is the only diameter that's used. Let's take a look at how this is implemented in OpticStudio 16. Here I have our standard Cook triplet open, and the easiest way to see the effect of the new Opto-Mechanical Semi-Diameters is on this biconcave lens here. This lens is defined by surfaces 3 and 4 in the layout, and you'll see that by default the chip zone is set to 0, so this is a relative diameter, and the mechanical semi-diameter is set to 5, so this is an absolute value. So let's say that I wanted a chip zone of 0.5 millimeter and a mechanical semi-diameter of 6. So 0.5 millimeter beyond that. I can define that here. I can do the same thing on the rear surface. And now you can see that I have a flange region defined on this optic without the need for dummy surfaces as would have been required in previous versions. The mechanical semi-diameter columns will not allow you to define anything less than the sum of the semi-diameter and the chip zone to make sure that you don't define non-physical dimensions. Also, an important thing to keep in mind is that the chip zone and mechanical semi-diameter are only available on rotationally symmetric surfaces and only in the professional and premium editions of the software. So if you open up OpticStudio 16 with a standard license, you'll see these columns grayed out. Some other things to keep in mind with optomechanical semi-diameters. For ray tracing purposes, the clear aperture, the semi-diameter, is the only portion of the surface that is actually seen by rays. The other regions are there primarily for visualization, drawing purposes, thermal modeling, those types of things. But rays will only interact with the clear aperture, the existing semi-diameter. You can also still define a semi-diameter margin as you would have previously using the values here in the aperture section of the System Explorer. Alternately, in the Surface Properties dialog, if you go to the Aperture tab, you have the ability to disable semi-diameter margins for a given surface. So during the beta test process, some users inquired as to whether they could turn off the margins so that the chip zone could be used for that purpose. And that's something that we now support with that setting in the Surface Properties dialog. As I said previously, these new semi-diameters are used across the program. Thermal analysis, which in previous versions of OpticStudio, we always assume that optics are held at the edge of the semi-diameter and expansion and contraction of radii, semi-diameters, thicknesses occurs relative to those fixed points. Now that fixed edge is considered to be the mechanical semi-diameter. So thermal analysis is more realistic when you're using lenses that have a mechanical edge to them. You'll also see these new semi-diameters defined if you look at the drawings that we provide. So if I open up an ISO element drawing and look at surface 3 and 4, you will now see the effective diameter, the clear aperture, 10 millimeters, the chip zone, the full diameter at 11 millimeters, and then the mechanical semi-diameter at 12 millimeters. So you can see that this data is now pulled into drawings. The information is also pulled into the cost estimator. So in previous versions, you may have had to do a lot of manual definition of edge apertures when getting cost estimates for prototypes. Now this data will be automatically included in the ISO element drawing, as I just showed you, and the cost estimator, of course, uses the data defined in the ISO element drawing. As I said before, there are also new optimization operands that allow you to constrain these new diameters. There are also new ZPL and ZOS API commands that allow you to control these values as well. So these new semi-diameters have been rolled out across the program, and you'll find that just about any analysis or capability that depends upon the diameters will make use of these new diameter definitions. Okay, the next feature I want to talk about is the fully instrumented non-sequential conversion tool. What this does is it takes the non-sequential conversion tool that we previously had and it improves it by optionally allowing you to convert your field points to source points in non-sequential mode and conjugate detectors that allow you to simulate spot diagrams in non-sequential mode. In addition, if your sequential system is defined at finite conjugates, there will be a slide object and a detector included in the conversion to give you the ability to do extended scene analysis or full field imaging. These capabilities are very useful for stray light analysis to see how stray light contaminates the spot diagram, and also for gauging the impact of optomechanics on clipping the beam or stray light. Let's take a look at how this works in a sample file. So I'm going to open up a sample file here that I have created specifically to demonstrate the new tool to convert to non-sequential mode. And it's the typical double Gauss photographic objective. And the Convert to NSC group tool is in the same location. If I click on it, you'll notice that there are several new options here. In just a few moments, I'm going to talk about the new design lockdown tool and the critical ray set generator. But for the time being, I'm going to focus on this section down here, which contains the same settings as you would see previously, the range of surfaces that you can convert, as well as an option to ignore errors and convert the file to pure NSC. I'm going to go ahead and convert it to pure NSC and also use this new option to add sources and detectors. Additionally, there's an option to save the non-sequential file with a new name, by default with the -non-seq name. You can rename that to anything you like. I won't worry about that for now, and I'll go ahead and click OK. And it will convert this system over to non-sequential mode. And you'll notice some things here. First, the optical system is defined on rows 4 through 10 with an absorbing annulus for the stop surface, the same thing we've done in previous versions of the software. But now we have 3 field points defined using the source ellipse and 3 conjugate detector rectangles. The original system was defined at infinite conjugates, so that extended slide object and detector that I spoke about previously were not defined in this conversion. So let me go ahead and do the following. Let me trace rays, and that should take several seconds here on this 4-core machine. And I'm going to take a look at the spot diagrams generated in non-sequential mode. And what we'll see is that the spot diagrams that are generated here are identical to the spot diagrams generated in sequential mode. And once we start considering stray light and optomechanics, we can then gauge the impact of those changes. So I went ahead and traced rays, and I'll go to the Analyze ribbon and open up the detector viewer here. And let me change to a false color scheme and a log scale. So this is the on-axis field point in this system. And you can see that it's a nice symmetric spot here. I can then take a look at my off-axis field points. Here is the middle field point that I can see that characteristic coma shape to. And then field number 3, same type of a thing. I can see that structure here. So this is something that you could have done in previous versions of OpticStudio, but you would have had to set up the sources and detectors yourself. So the tool now makes it that much more convenient by automatically doing the conversion for you, placing the detectors centered at the nominal location of the chief rays for each field point, and giving them sufficient size and resolution in order to see the detail on these spots. Okay, so those are some of the improvements that we made to the non-sequential conversion tool. Let's take a look at the two other capabilities that you saw incorporated into the non-sequential conversion tool. The first is the design lockdown tool. This tool is used to perform some common tasks that are necessary for preparing a sequential optical system for manufacture. Among the things that it does are it fixes the apertures in your optical system, it replaces vignetting with apertures, it converts to object-based fields, it removes any solves that you might have, and it also rounds defining values, thicknesses in particular, to some number of decimal places that are appropriate for the precision that you need for manufacturing. If I go into OpticStudio, I'll go back to my original double Gauss sample file here, and I can show you where that's done. I've already run the design lockdown tool on this particular system, so I'll just show you where it is. It's in this new production tools group in the tolerance ribbon. And if I click on it, you'll see that same dialog here where you have the ability to save the modified system with a new name, round your thicknesses, and optionally you can exclude pickup solves during the solve removal. So this is one of the tools that enables manufacturability considerations to be performed. And again, these are things that you would have been able to do manually in prior versions, but it now automates this process. A related tool for preparing an optical system for manufacturing is what we call the critical ray set generator in sequential mode and the critical ray tracer in non-sequential mode. What this will do is it will trace a series of what are called critical rays or reference rays in sequential mode and save the data for those rays, their coordinates and direction cosines throughout the optical system. And those rays can then be traced in non-sequential mode. And in non-sequential mode, when you run the critical ray tracer, you can define a tolerance cutoff whereby if the critical rays differ in non-sequential mode by more than some amount from the reference coordinates and directions in sequential mode, you can have a pass-fail criterion that's quickly assessed. This again is useful for determining the impact of optomechanics on ray tracing in an optical design. So if I come into this optical system, I can click on the critical ray set generator. Okay, and actually maybe I didn't run the design lockdown tool on this system. Let me do that first here and click OK. So it's going to fix a lot of those parameters for me. You can see that all of the semi-diameters are now user-defined. And now when I run the critical ray set generator, I can see the dialog here. So it allows some number of rays, some pattern of rays that you choose. And the output file you'll see here is what's called a CRS file, a critical ray set file. And you have some other options in terms of defining on-axis fields only, wavelength, so on and so forth. Let me go ahead and click OK here. All right, and I've already generated this file before. I'll go ahead and overwrite it. Now that the critical ray set is generated, I will once again convert to non-sequential mode. And once that's done, I can then trace critical rays in non-sequential mode. So let me go to the Analyze ribbon to the Trace Rays section, and here you will find the corresponding tool in non-sequential mode, the critical ray tracer. If I click on that, the settings that it needs are the critical ray set that I just created, and also the tolerances on position and angle that dictate the threshold between passing and failing. Okay, and you can optionally show all of the data that you're looking at as well. So if I click OK, the first thing that you'll see is it shows me all of those marginal and chief rays that it traced. And what's good is that they're all passing at this point. So I've done nothing but convert to non-sequential mode. So 100% passing is good. Now what you can see is if I start perturbing the optical system, let's say I start shifting one of these lenses in the Y direction, what you'll notice now is that some of the rays are failing, which means that their position and or angle is more than the tolerance that we've specified, different from the reference coordinates and angles in sequential mode. So this is really valuable, again, if you are bringing in opto-mechanical components or doing stray light analysis to determine whether the changes that you're making to an optical system are impacting the rays, the designed rays that you need to make sure get through the optical system with certain properties. All right, a couple more features that I want to talk to you about here before we wrap up. In OpticStudio 16, there are additional non-sequential objects as detectors that are supported. So now you'll find that most non-sequential objects can be detectors, whereas in previous editions, you'd find that maybe 5 or 10 objects, specifically objects that were natively faceted, could be detectors. Things like polygon objects and STL imported objects. Well, now probably 90+% of objects in non-sequential mode can be detectors. The pixelation of the detectors, as previously, is controlled by the object drawing resolution in the object properties dialog, and the results are visible either in the shaded model layout or also in the text listing of the detector viewer. Okay, let me open up a sample file here that illustrates that. So here I have a sample file which is the projection engine for a digital projector that uses a couple of lens arrays to homogenize the beam. And what you can see is that for each of these components, in the object properties dialog, I've checked the object is a detector option here. And again, the resolution of the pixelation is controlled by this drawing resolution here in the Draw tab. And what I can see in the layouts now is, after I've run a ray trace, the detailed distribution of energy on each of these objects. So I get a lot more visual information about where the hot spots on an object are. So this really takes stray light analysis and other types of non-sequential analyses to a new level where you can visualize the distribution of energy on just about any object in your optical system. This data is also available in the detector viewer. If I select any of my objects that are detectors, I can look at the text view of those objects and see that data there as well. We don't plot it like this in the detector viewer because taking a three-dimensional object and viewing the distribution of irradiance or luminance, what have you, on a two-dimensional detector viewer is potentially misleading. So we don't show it in that format. So again, this is another new addition in non-sequential mode, the ability to look at light distributions on just about any object that we support in non-sequential mode. The last feature I want to talk to you about today is a new wavelet construction method for the Huygens PSF in sequential mode. So previously, the Huygens PSF calculation always used a planar wavelet construction method. And this method works very well for optical systems that are forming a diffraction-limited point spread function. However, there are a lot of advanced optical components being designed these days that don't necessarily meet that assumption. One specific class of these objects is discrete or pixelated diffractive surfaces or hologram surfaces. As an example here, we're looking at the phase map of a very complex diffractive surface, and this surface has been designed to take collimated light and form a tachometer display, a tachometer distribution of energy. And previously, the Huygens PSF could not be used to accurately simulate this distribution of energy after rays propagate through this phase mask. Using this new spherical wavelet construction method, we can now accurately simulate these very complex diffractive surfaces that don't form a single point spread function that's diffraction limited. The choice of whether to use the default planar wavelet construction or new spherical wavelet construction method is automatically determined in the software, so you don't need to worry about setting anything in order to get accurate results. Another thing that this is useful for is looking at things like through focus PSF and looking at the evolution of a beam away from focus as well as at focus. Again, this is something that previously the Huygens PSF would have been unable to accurately simulate, but now this new addition really extends the range of optical systems that the Huygens PSF can be used to simulate. So that's the main features that I wanted to talk about in OpticStudio 16. We thank you for attending this webinar. As I said before, OpticStudio 16 is now available for download from our website. If you check for updates in the help ribbon of a previous version of OpticStudio, it will also tell you that there's a new version that's available for download. In addition to all of the features that I've talked about here, there are many more capabilities that we've added to the software. You can see the complete description that's available in the release notes on our website. If you have any questions or comments after this webinar, feel free to email support@zemax.com with those questions and we'll respond to you promptly. Thank you once again for attending this webinar, and we hope to see you at a future webinar.